A lot of the risk in modern infrastructure is no longer hiding in the parts we used to fear most. Sometimes it is a bad kernel bug. Sometimes it is a broken DNS signature at the TLD layer. Sometimes it is a GitOps upgrade that changes behavior under your feet. And sometimes it is an AI agent with way too much authority and not nearly enough guardrails. This week has a little bit of all of that. And the common thread is pretty simple. Control planes are brittle, automation is powerful, and identity still decides whether a mistake stays small or becomes a crater. Hey, I'm Brian Teller. I work in DevOps and SRE, and I run Teller's Tech. This is Ship It Weekly, where I filter the noise and focus on what actually changes how we run infrastructure and own reliability. Show notes and links are on shipitweekly.fm. If the show's been useful, follow it wherever you listen. Ratings help way more than they should. And if you're watching on YouTube, subscribe there too. We've got 6 main stories today, then the lightning round, and we'll wrap with the human closer. We're starting with the PocketOS and Cursor incident because it is probably the most instantly gripping story in the set and also one of the most revealing, not because AI made a mistake, because an agent got access to something it should not have had in the first place. Then we're going to the .de DNSSEC outage and Cloudflare's response, which is one of those reminders that the internet's deepest layers are still capable of ruining everybody's afternoon all at once. After that, Bluesky's Outage Postmortem, which is a really good incident story because it is weird, specific, and painfully real. Then Argo CD with version 3.1.16 being the last 3.1 release, and version 3.4.1 bringing a behavior change that people really do need to notice. Then the Linux kernel copy fail bug, CVE 2026 31431, because active exploitation plus broad Linux exposure is not something ops teams get to casually defer. And finally, Google Cloud Agent Identity and AWS MCP Server GA, because the cloud platforms are starting to treat AI agents as first-class actors instead of weird sidecars bolted onto existing IAM assumptions. Story 1. PocketOS and Cursor is really an identity story. Let's start there. This week's on-call brief summarized the incident this way. On April 25th, a Cursor AI agent reportedly deleted PocketOS's production database in under 10 seconds after a credential mismatch led it to access an API token it should not have had. The result, according to the reporting cited in the brief, was full production data loss, including backups. This is obviously a wild headline, but I think the more important part is not the speed or even the AI branding. It is the access path. Because if an agent can see a destructive credential, then the real problem started before the agent ever took action. That is why I think that this story is more useful than just look at what AI did. It is really about credential sprawl, environment separation, and what happens when people start granting machine-assisted workflows access that was probably too broad even for a human. An AI agent did not invent bad blast radius design. It just exercised it fast. And that is the practical takeaway I'd want teams to hear. If you are adding AI coding agents or operational agents into real environments, you do not get to treat identity as a cleanup task for later. The difference between helpful automation and production incident is often just one token, one role, one environment boundary, one missing approval step. So yeah, this story is dramatic, but the lesson is boring, and boring is good. Scope the credential. Separate staging from prod. Assume the agent will eventually try something dumb, overconfident, or surprising, because sooner or later it will. Story 2. The .de DNSSEC outage is a reminder that internet plumbing still has global blast radius. Next up, the .de outage. Cloudflare says that on May 5th, at roughly 1930 UTC, DENIC the operator for .detld started publishing incorrect DNSSEC signatures for the .de zone. Any validating resolver that received those records was required by DNSSEC rules to reject them and return serve fail. Cloudflare says 1.1.1.1 was no exception. That means a bad cryptographic state at the TLD layer was enough to make huge numbers of .de domains effectively unreachable. That is a great outage story for ops people because it is one of those failures where everything is technically working exactly as designed, and that is the problem. DNSSEC is there to make sure responses are authentic. The signatures were wrong. Resolvers did the correct thing and refused to trust the data. And suddenly, correct behavior becomes mass breakage. That is such a brutal but important reliability lesson. Security mechanisms do not eliminate failure, they sometimes concentrate it. Cloudflare's write-up is also good because it walks through mitigation trade-offs instead of pretending there's always a clean answer. When the trust anchor above you is wrong, your choices get ugly fast. Do you keep strict validation and break reachability? Or do you apply a temporary exception and accept the risk of bypassing a protection that exists for a reason? That is not really a DNS-only lesson either. It is a control plane lesson. When a higher order authority goes bad, the downstream systems that trust it do not fail independently. They fail together. So if I'm taking one operator lesson from this, it is this. Any system built on centralized trust, centralized signing, or centralized metadata needs a very honest failure mode conversation. Because when the thing at the top is wrong, your elegant security chain can turn into synchronized outage machinery very quickly. Before we get to the next story, a quick note from this week's sponsor, GuardSquare. If you are building mobile apps, good enough security is usually a problem waiting to happen. GuardSquare focuses on actually protecting your code, in addition to scanning it. That means code hardening, runtime protection, testing, and visibility into what's happening once your app is out in the wild. So if you are responsible for shipping and securing mobile apps, Android or iOS, definitely worth taking a look at guardsquare.com. All right, back to the show. Story 3. Bluesky's outage postmortem is the kind of weird incident story worth studying. Now for my favorite kind of reliability story. Bluesky published a postmortem for its April outage, and the post says that the service was intermittently down for about half its users for around 8 hours. Jim Calabro's write-up says they saw pretty quickly that they were exhausting ports, but the harder part was figuring out exactly where and why. The root issue involved mem-cached traffic, ephemeral port exhaustion, and a cascade where the debugging path became part of the failure path. What makes this one so good is that it is not just we ran out of ports. The postmortem explains that logging used blocking write syscalls, and under the load of trying to log huge volumes of errors while still serving traffic, the Go runtime spawned far more OS threads than normal. Bluesky says that extra thread pressure then hit the garbage collector, contributing to the broader failure cascade. The write-up also shows a custom dialer workaround that randomizes loopback IPs to avoid ephemeral port exhaustion on a single address after restarts. That is such a real incident pattern. The original fault hurts. The observability path amplifies it. The recovery path gets noisy, and then the system that is supposed to help you reason about the incident starts participating in the incident. That is not hypothetical. That is production. And I also like the honesty in the write-up. Bluesky basically says the signal was there, but it was buried in too much noise, and that you need the discipline and the metrics to cut through it. That lands because it is true. A lot of outages are not invisible. They're just obscured by too many symptoms arriving at once. So my takeaway here is not just watch ephemeral ports. It is broader than that. Watch where your debugging strategy becomes a scaling liability. Watch where synchronous behavior hides inside paths you think are harmless. And watch for failure modes where saturation causes your tooling to become part of the blast radius instead of part of the recovery. Story 4. Argo CD is giving people one quiet end of life and one not so quiet behavior change. Next up, Argo CD. Argo's version 3.1.16 release is the final release in the 3.1 series. The release notes are very explicit. As of May 6, 2026, 3.1 has reached end of life and will no longer receive bug fixes or security updates. The same release notes tell operators to move to a supported version, meaning 3.2, 3.3, or 3.4. That alone is worth a mention because GitOps tools have a way of becoming background furniture. Teams stop thinking about the controller version because the controller is just there doing its thing, right up until the day it matters a lot. But then there is the second part. Argo CD version 3.4.1 is the first release in the 3.4 series, and the release notes call out an important change. Following Helm 3.19.0, Argo CD now aligns its interpretation of Kubernetes cluster version with Helm's behavior. On-call brief points out that this affects application sets that filter clusters by Kubernetes version. That is exactly the kind of change that looks tiny in a release note and then quietly breaks assumptions in real environments. So for me, this is a classic operator story. Not sexy, not viral, very real. One branch is dead. One branch changes parsing behavior. And if your GitOps setup depends on version-based selection logic, you need to actually test that logic instead of assuming a minor release means minor consequences. The practical lesson is simple. Treat controller upgrades like control plane changes, not package refreshes, because that is what they are. If the thing deciding what gets deployed, where, and when changes how it interprets your environment, that is production behavior, not housekeeping. Story 5. Copy fail is the kind of kernel bug you move on quickly. Now to CVE 2026 31431, also known as copy fail. NVD shows that this Linux kernel vulnerability is in CISA's known exploited vulnerabilities catalog, and CISA's entry gives federal agencies a remediation due date of May 15th. The flaw is an incorrect resource transfer between Sphere issue in the Linux kernel, and the reporting around it says it enables local privilege escalation to root on a wide range of Linux distributions. AWS's security bulletin says that with the exception of specifically listed services, most AWS customers are not affected. But it also lists update timelines for affected services such as BottleRocket, ECS on EC2, EKS optimized AMIs, and EMR. So this is one of those stories where not everybody is affected should not turn into nobody on our side is affected. You still have to inventory what you run. That is the operational lesson here. When a kernel LPE lands in KEV and there is an active exploitation, this is not the time for vague patch queues. This is the time for concrete exposure review. Which hosts? Which images? Which managed services? Which self-managed nodes? Which maintenance windows? Which compensating controls until patched? And honestly, the thing I always come back to with stories like this is that kernel issues collapse abstraction layers really fast. You can have immaculate Kubernetes policy, good IAM, strong workload boundaries, and still get wrecked if the shared kernel underneath is vulnerable and unpatched. That is why these bugs matter. They turn every higher level control into a best effort suggestion until the underlying system is fixed. Story 6. Google and AWS are both telling us agents need first-class infrastructure identity now. Last main story. I wanted to put Google Cloud Agent Identity and AWS MCP Server GA together because they are different products, but they point in the same direction. Google Cloud's new IAM post says that the AI era needs a different security and governance model for autonomous agents, and it introduces agent identity as a new first-class principal type, distinct from human identities and generic service accounts. Google says these identities are built on SPIFFE, are cryptographically protected and strongly attested, and can be used to authenticate to MCP servers. cloud resources, endpoints, and other agents. It also ties this into agent gateway policy enforcement, least privilege controls, and runtime defense. AWS's side of the story is different in implementation, but similar in intent. AWS says that the AWS MCP server is now generally available and gives AI agents and coding assistants secure, authenticated access to AWS services through a small fixed set of tools, using existing IAM credentials. The official announcement frames it directly around the problem people keep asking. How do you give an agent real AWS access without just handing it keys to the kingdom? That is why I think these stories belong together. Both clouds are basically admitting the same thing. Agents are not side features anymore. They are becoming infrastructure actors. And once that is true, the identity model has to change too. Not just more service accounts, not just more static tokens, not just vibes and trust. Real principles, real boundaries, real policy, real auditability. So my read is that this is where cloud identity is headed next. Human identity was phase 1. Workload identity was phase 2. Agent identity is shaping up to be phase 3. And if teams do not start treating that as real infrastructure design now, they're going to rediscover all of the old machine identity mistakes with an LLM in the loop and a much faster failure path. A few quick ones before we wrap. Cilium published lessons from securing CI/CD for an open source project. And the reason that I like it is because it is practical. On-Call Brief highlights controls like tighter CI/CD security practices and lessons learned from operating a real open source pipeline. That is worth a read for anyone treating GitHub Actions hardening like a someday project. Valerio version 1.18.1 RC2 includes a security fix for CVE 2026-27141 by bumping golang.net/x/net to version 0.51.0. That is the kind of small release note that matters a lot when you realize it closes a known vuln in a tool people trust for recovery. Google's release notes also carry a couple of quieter but real operational changes. Google Ads and related measurement APIs move to a 37-month retention policy for granular performance stats starting June 1st. And Google's Distributed Clouds Kubernetes 1.35 platform update now requires cgroups v2, with cgroups v1 no longer supported for creation or upgrades. Those are not flashy changes, but both can absolutely break assumptions if nobody notices them. AWS also published a cross-region disaster recovery walkthrough for Amazon EKS using AWS Backup. The post walks through creating backup vaults in source and DR regions, running on-demand backups, and initiating cross-region copies. It is not a glamorous story, but it is the kind of thing that people say they care about right up until they realize they have never actually rehearsed it. I think the human thread underneath this week's episode is that modern reliability work keeps getting squeezed between two kinds of failure. The first kind is old and familiar: kernel bugs, network trust failures, port exhaustion, controller upgrades that changed behavior, core infrastructure problems doing what core infrastructure problems have always done. The second kind feels newer: AI agents with too much authority, new cloud identity models for autonomous systems, tooling layers that quietly become control planes, build and operational systems that act like sidecars until the day they absolutely are not. And what is tricky is that these two categories are not separate anymore. The old failures now happen inside environments shaped by the newer automation. The newer automation inherits the blast radius of the old infrastructure, and ops teams end up responsible for both at the same time. So I think the real takeaway this week is pretty simple. Reliability is not just about uptime anymore. It is about authority. Who and what can act, what it can touch, how fast it can fail, and whether your system design assumes mistakes will stay local when they almost never do. That sounds abstract until you line up the stories. A TLD signs bad data and millions of lookups fail. A social platform runs into port exhaustion and logging makes it worse. A GitOps controller hits end of life, while version parsing changes in the next branch. A kernel bug drops into active exploitation. An AI agent sees the wrong token, and production disappears. Different systems, same lesson. Small authority problems turn into large reliability problems very quickly. All right, that's it for this week of Ship It Weekly. Quick recap: the PocketOS and Cursor database wipe, and why it is really an identity story. The .de DNSSEC outage, and what happens when the trust chain itself goes wrong. Bluesky's outage postmortem, and how observability can become part of the incident path. Argo CD 3.1 going end of life, while 3.4 changes behavior. Copy fail, and why active kernel exploitation still cuts through all the higher level abstractions. And Google Cloud Agent Identity plus AWS MCP Server GA, because the cloud providers are starting to formalize agents as real infrastructure actors. Then in the lightning round, Cilium's CI/CD security lessons, Valerio's CVE fix, Google's retention and cgroup's v2 changes, and AWS's cross-region EKS disaster recovery. Links and show notes are on shipitweekly.fm. You can also find the video versions on YouTube. And if you want the source stack before the episode lands, check out this week's on-call brief. If this episode was useful, follow or subscribe wherever you listen, and send it to the person on your team who still has to explain that reliability problems are not just outages anymore. Sometimes they are identity problems, tolling problems, and authority problems wearing outage clothes. I'm Brian, and I'll see you next week.